Hello everyone, my name is Anvita Bansal and we are back with the last problem of our SD sheet from arrays section. The problem for today is swapping pairs make sum equal. So let's move to the problem and understand this one. You can go to the SD sheet and click on this problem. So the problem says that you are given two arrays of integers a and b of size n and m. Your task is to check if a pair of values, one value from each array, exists such that swapping the elements of the pair will make the sum of two arrays equal. So what do you mean by this? What does this problem mean? So this problem says simply that can you find one element from A such that you remove it from A, let's say any element you remove from A, you put that in B and do the same thing in B. You remove one element from B and place that. Do not literally place it, but just assume if that element of B was present in A. Now the new array that you visualize, find the sum of that array. Is the sum of A and B equal now? So if you find such a pair, then you have to return 1. Otherwise, you will return -1. So the problem is about this. So let's move to the whiteboard and understand this. So I have already written two test cases here for you to understand. So what do we mean here? The question says that, first of all, let's say, what is the, if I were to calculate sum of A, what is the sum of A? 1 second. Tell me what will be the sum of A. Sum of A would be 4 plus 1 plus 2 plus 1 plus 1 plus 2. So that will become 7, 8, 9, 10, 11. 11 is the sum of A, right? Okay. What is the sum of B? Calculate the sum of B. The sum of B will be 18, right? Sorry. Fine. That is the sum of B, 15. 3 plus 6 plus 3 plus 3. Okay. Now you have to find a pair such that one element is in A, other element is in B, and you remove from A. Let's say you remove some element from A. So the sum will become, let's say you remove some element, sum becomes 11 minus x now. And then you add that element to B. Basically, you will add that to this array. And you do the same thing with B. You remove that one element from your array B, let's say that is Y, and assume that you have added. I'm saying assume because you don't have to literally modify the arrays. Your task is to find such X and Y from A and B respectively, such that when you remove from B and add it to A, this time it will be Y. So the sum that is formed, they should be equal. So your target is to find such X and such Y. Even if it is not very well understood, just wait, so have patience for some time, you'll understand what we want to do. So basically you are trying to find pair from of X comma Y. Let's say X is from A, Y is from B, and this pair should be such that when you remove from A and add it to B, now the sum will be, let's say there is this 3, 6, and let's say some element, whatever it is, you cannot figure that out. Now the condition of array will be something, right? Some modification has been done. Now the sum of A after those modifications should be equal to the sum of B. That's what your target is. So the very first approach that will come to your mind is the brute force approach. Would be what? You check for such pairs in both the arrays, right? Check for such. How are you going to iterate the array such that you find some, let's say X from A, Y from B, and what you want to do is that whatever the sum of A is at that point in time, you will remove that A of I and add some B of J. Let's say you calculate this sum. Let's say this is your sum A. Sum A is actually this total sum. You can write it as total sum also. Let's say current sum, cur of A. Cur of A is holding the current sum, and sum of A is the total sum that we calculated. And similar thing you are going to do for B. Cur of B is going to be your sum of B minus, let's say, what are you removing from B? You are removing B of J from B, and you are adding A of I to B. So you will get some sum. So you will check if cur of A is equal to cur of B. Then in that case, return 1, otherwise return -1. Right? So if I were to write a nice pseudocode here, what would it be like? It would be something like this. So you are iterating over A, let's say for all indexes from I equal to 0 to, let's say, inclusive n minus 1, right? Then similar thing for all indexes, let's say from j equal to 0 for m minus 1. You don't need to have both the arrays of similar length. You might not have that, because the question clearly says that length of A shall be considered as n, length of B shall be considered as m. In some cases they might be same, but not in all the cases. So for that, j iterates over 0 to m minus 1 at index. Now what are you checking for? Let's say your I is at 0, you are at 0th index, and your j is also at 0. Your j is also at 0. What are you checking? You are checking, let's say, for assume that your x is 4 and y is 3. Now what you want to do is, let's say 4 and 3 is that pair of in after which, on doing certain operations, your scenario should be like that: you remove 4 from A will be devoid of 4, and that will be added to B will be added with 4, and you took 3 from B, so that will be added to A and subtracted from B. So now the scenario is something like this. So how will the array A will look like? A will look something like this. 3 is added to A, 3, 1, 2, 1, 1, 2. And B is something like this. 3 is removed and 4 is added. So let's replace it with 4. Swapping, we are swapping the elements. 4, 6, 3, 3. Again, I'm repeating, you don't need to literally swap it in your code. You just need to make the calculations if such was the scenario of your array. Now, what is the sum of A? So the sum of A is 3, 1, 4, 2, 6, 7, 8, 9, 10. And the sum of B is 10, 3, 13, 3, 16. Are these sum equal? Can you see these sum to be equal? No, they are not. 10 is not equal to 16. So that means our assumption of considering 4 and 3 as one such pair is wrong. So you keep on checking for all the pairs. Let's say you increase your j. Now your j is here. So your pair would be 4, 6 now, and you do the same operations. Again, if you let's check with 4 and 6. Let's dry run for 4 and 6. If 4 is removed from A minus 4 and added to B, and 6 is removed from B and added to A, what will be the sum now? So the sum of A initially was 11. You removed 4, right, and added 6, basically plus 2. So your sum will become 13 here, right? And in this case, in the original sum of B was 15. You are again, what are you doing? You are subtracting 2. Overall, the sum becomes 13. So we have got sum equal in this case. So if I'm considering 4 and 6 as one pair, I can definitely say that removing 4 and adding 6 in A, and removing 6 from B and adding 4. Basically, I'm swapping 4 and 6 from A and B. So I am getting one pair which is making my sum A equal to sum B. So I can easily return 1 in this case, right? So what are you doing now? What are you doing? You are basically, for every iteration in A, you are making m number of iterations in B, right? And you are checking if what is your current sum now. Let's say current sum of A will be sum of A minus A of I plus I am removing a of I and adding b of j, and current sum of b would be like this: sum of b minus b of j, and I am adding a of I. A of I and b of j are my pairs, right? I am checking this. If I will check if cur sum a is equal to cur sum b, return 1, otherwise return, else return -1, right? This is your pseudocode. Now what is the time complexity for this pseudocode? So you can see in the dry run also, for every iteration in A you are trying to find the pairs in P, right? So for I0 you are going from J0 to M-1. For I1 you're going from J0 to M-1. So basically M times you are running I, M times N is your time complexity in this case. No extra space taken, so space is not, no extra space has been taken, but your time complexity is of cross N, right? M or n cross M, same thing, but yeah, ideally if I were to write it, it's n cross M, right? So can we optimize this approach? Is there a way to optimize this approach? Let's see. Can I optimize this approach such that, let me check if you guys can see my screen, right? N square, if the length of both the arrays is same, that is n. But if length of both the arrays is not same, not equal to n, in that case it will be equal to length of A multiplied with length of B, is the time complexity. Now we want to optimize this approach. So how do we optimize it? In the very beginning I told you that we want to actually find that, let's say x comma y is my pair. Okay, A minus x, let's say A is the sum of A, and minus x plus y, where x is taken from A, y is taken from B. Thus, now whatever sum I am getting after removing x and adding y should be equal to whatever element I am removing from B's sum. Let's say that is y, because from B I am removing y, and adding an element from x. Let's say that is x, right? So this should be equal. The sum, can we do it something like this? A minus B should be equal to, just transpose this, x, this will become 2x, and minus of 2y, minus y and minus y. So if you just look at this way, x minus y, this is 2x minus y is equals to A minus B, right? So I want to find a pair such that x minus y should be equal to half of A minus B. You getting this thing? What I'm doing here is I want to find two elements from A and B such that the difference of these two elements, difference of x and y, should be equal to difference of their actual sums divided by 2. That should be the case. So what is the sum of A? We calculated to be 11. Sum of B, I think we calculated to be 15. I'll just cross check it. 4, 5, 7, 8, 9, 10, 11. Fine. Okay. Now what is A? A is 11. Sum of B is 15. And divide by 2. So basic. Also you need to understand this for a reason, that whatever difference we get, that should be divisible, exactly divisible by 2. This is -4 and it is exactly divisible by 2, so I am going to get -2. So why I'm saying exactly divisible, because see, x and y are two integers, right? So the difference of two integers can, it at any time, be something like 0.5 or 0.75, or let's say half. Can it be in fractions at all? It should also be some whole number, You getting this point? Whenever I have two integers, whatsoever they are, their difference should also be some whole number only, right? It can be anything but not in fractions. So, and mathematically in coding, if let's say this was not, the difference here was not divisible by 2, let's say this was 10 and then this is 15. What is 10 minus 15? It is minus 5, and minus 5 is not divisible by 2. And still, if I do minus 5 divide by 2 in code, I am going to get minus 2. You know that for a reason, right? So I will put a check only if this difference is the whole, basically this difference is divisible by 2. Only then I am going to get such pair, otherwise no such pair will exist. If sum of a is 10 and sum of b is 15, you can do anything, but you are not going to get two such whole numbers from a and b whose difference will be equal to 2.5. Why? Because we know that minus 5 by 2 in coding, it is going to give us 2 only. But for a fact, actually, this is going to be minus 2.5, right? And we know that no such two integers will exist whose difference will not be a whole number. Okay, so this is one check that you need to keep. Now, moving ahead, what I wanted to explain using this kind of equation that we have written here. Okay, so how can we solve it? I am going to discuss the optimized approach. What was the time complexity that we used earlier? We used a time complexity of log O of n cross m, right? Which was the time complexity when we were using two for loops, right? In this case also, we can use another method, which is not the optimized one, but yeah, similar thing that we were doing earlier. We were checking for a pair such that for I 0 to n, then there was a nested loop for j equal to 0 to m minus 1, right? There was this another for loop, and we were checking that whatever was a minus that a of I plus b of j should be equal to b minus b of j plus a of I, right? We were checking for this. If that was true, we were returning true. In the similar code, if we check for this condition, the equation that we have written on the left, just check for that. Then also the time complexity will remain same. Everything is going to remain same. Only that just the method is different. Only method is also different. Same only. The only difference is this mode of calculation, right? Earlier you were checking that way, now you are checking that a of I minus b of j, if that is equal to this some, let's say, target. And also you will define some target above. Target is equals to, what is it? Your total sum that we must have written above. So a minus b divided by 2. And I have told you, before we calculate target, we are going to check if a minus b remainder 2 is equal to 0, only then your target is this. Otherwise you simply return minus 1. End of question. No such pair is going to exist. So this is again the similar O n cross m time complexity approach, not the optimized one. Just the methodology of calculation is different. Okay, now coming back to the optimized approach. What do we want to do in this case? So let's do one thing. If I sort arrays. Okay, if I sort my arrays, A will look something like this. A will become, considering this array, A will become 1, 1, 1, 2, 2, and 4, right? Your B will become 3, 3, 3, 6. Got it? Why am I doing this? I'm again going to make use of this equation. I am going to check at any point in time using one loop. Let's say your I starts from 0, your j starts from 0. Now checking for it. While what? I should be less than the length of that array, and j is less than the length of B's array, right? B array. what are you checking? Check for this condition. First thing, that for target you have already found. Target is a minus b divided by 2. And to find the target you have already checked if a minus b remainder 2 is equal to 0. Only then you are calculating this, otherwise you are returning minus 1 to the problem. Okay, so this thing you have already, let's assume that you have written this above this while loop. Okay, now I'm just telling you the function that we are, basic thing that we are going to do in our while loop and how it is optimized approach. I hope this target thing is clear. We will write it in the code and you will understand it. Okay, so at any point in time, what I'm doing is I am checking if, this is important to understand. Let's say if at any index, if a of, let's say I, not let's say, it is a of I want to check for x and y, right? X will be a of I, b will be, y will be b of j. If this value, if it is exactly equal to this value, that is half of a minus b that we might have calculated using target, if that is equal to target, simply what you are returning, you are returning 1. Otherwise what can be the case? Else if a of I, this difference minus b of j is less than target, is less than your target value, right? Let's say your target is 6, right? And your x is, let's say your target is 6, let's say your x is, let's say 10, and your y is, let's say, it should be less than your target, right? Let's say it is 8. Okay, fine. So what is x minus y in this case? X minus y is 2. 2 is less than 6 for sure. And let's assume that you have an array in which a starting index is 10, then, and it is sorted array. We are considering sorted. Next is 12, 13, and so on and so forth. Let's say b, since we have considered y as 8, so let's start with 8. Then we have 9, let's say, and then and what do we have? 4, and so on and so forth. Okay, so when you check for 10 and 8, the difference is 2. Difference is less than your required target. You want 6 and it is difference is less. So how are you going to get the target? For sure, we know that whatever position we are at in b, if I just increment ahead to the next position, I am going to get some bigger value. So 10 minus some bigger value means, some earlier it was 8, now if I'm going to increase this value, my difference is definitely going to increase or not. 1 second. So your target, I think I just mixed it up. 1 second. What I want to explain you here is that if your difference is less than target, let's say this is 4, this is 3, right? Your difference is 1. X minus y is 1. And your target is what? The sum is 11, here the 15. Your target is 11 minus 15 divided by 2. What is that? It is minus 2. Okay, so in this case, when you check for 4 comma 3, your 4 minus 3 is equal to 1. 1 is greater than minus 2. So if this difference is greater than minus 2, what are you going to do? You want that difference to reduce. In order to reduce that difference, what can you do? Either you can move ahead in a or you can move ahead in b. But what should you do ideally? If you move ahead in a, now you will be at 1 and b is still at 3. So 1 minus 3 is going to be minus 2. Now you are getting a pair which is exactly equal to your target. So what do? You simply incremented the count of I. Why did you do so? I think I just did a dry run on a wrong array. I want it in sorted array. So 1 minus 3 is minus 2. In this case, you are returning 1. 1 minus, now you simply return 1, it won't matter. Now let's say you are at this index and you are at this index, right? 2, 1 comma 3 is 2 comma 3. Your difference is what? 2 minus 3 is minus 1, and the difference you want is minus 2. So you'll increase your value in a or you'll increase your value in b. If you increase your value in A, it is again 2 minus 3 is again minus 1. No difference. 4 minus 3 is 1. So as and when you are increasing your value in A, your difference is what? Difference is incrementing or decrementing. That is the pattern you need to understand. It is difference is decreasing. It was minus 1, it became 0 at some point. Now it is being like this, incrementing, incrementing, incrementing. And if you increase in A minus B, what will happen if you increase A? If you increase A, your difference will increase. If you increase B, your difference will decrease. So if your difference is less than target, that means you want to increase the difference. So you will increase the difference by moving ahead in A. And if A minus B is greater than target, it is greater than target, that means it is you want to decrease your difference. And to decrease your difference, what are you going to do? You want to minimize the difference. You will increase the value of B, right? So you will increment the count of J. That is what we are doing. Is it clear till here, everyone? You don't have to worry. I'll just dry run over another case also and you will understand. So this is what you are doing in the optimized approach. Let's first try to code it and then come back to the question. Understand it. Okay, let's move ahead. So what are you doing? And first thing is you're calculating the target. So let's say for that I should have some A0. And since it's in long, we would like to take it in long only. Long of sum A equals to 0, long of sum B equals to 0, long of target equals to 0. Calculate the sum of A and B. That's what you want to do, right? So for I and D, I 0 I is less than your N I plus plus. A of I. Same thing you will do for B. I is less than M sum of B. Fine, that should be equal to. Okay. Now you keep a check. If sum of A minus sum of B, remainder 2, is equals to 0, what are you doing? You storing this value of that we discussed in this equation. This is what we are trying to store. Target is equal to sum of A minus sum of B divided by 2, right? Else what? Simply return -1. No such pair is possible. I will tell you with example why returning -1 is the right thing to do here. Okay, so we have calculated target. Now we will work on our array to check if such pair exists or not. While your I fine. What are you doing? You want to calculate x minus y. What is x? That is A. So int, let's say current sum is equal to A of I minus B of what? J. Right? If current sum or sum is equal to your target sum that you wanted, you will return 1. Otherwise, else if your cur sum it is less than your target sum. If A minus B is less than some target, right? It is less than target. That means what can you do so that you can reach till target? You are going to do I plus plus. Why? X minus Y. See, X minus Y, you want to, this is still very less than your target. Let's say this was your target. Let's say in graph, there is some X, there is some second. 10 minus 2 is what? 8. Fine. And let's say your target is 12. So you want to increase this value. In order to increase this value, what if I increase this value? If I increase this value, let's say I increase it, just for your understanding, by 1, it will become 11. 11 minus 2 is what? 9. So target has increased by 1, but still it is not equal to target. So if I keep on increasing my value of A, I at some point, if I got target 12 as the difference of these two values, so let's say I increase the value, and at some point in time I reach 14. 14 minus 2 is what? 12. So I have got my difference equal to target. So I can say this is one pair. And if I want to increase the first value, that is the value of X, I know that I have already sorted my array. So A looks like this: triple one, triple one, two to four. So if I increment the count of I index, I am going to get either equal or a bigger number in array, bigger element in A. I'm not ever going to get a smaller element than what I already have. And if I want to increase the value of A minus B, because it is smaller than target, I should increment the count of I so that I can get a bigger number in A. And vice versa. What is that? If your target is actually greater than your required, this difference is greater than your required target. Let's say your target is 5 and what you are currently getting is 8, right? So in this case, what are you going to do is you should increase the value of this number so that your difference shrinks. If I make it 3, 10 minus 3 will be 7. If I make it 4, 10 minus 4 will be 6. So this difference will keep on decreasing. If I make it 5, so in order to get a bigger number of this value, that is x minus y is y, I should increment the count in of index in B, so that B is also sorted. Whenever I go ahead, I am going to get either equal or a bigger value in B. So that is why here the count of J is being incremented. I hope now it is very clear to you all, right? Otherwise, else you are doing J plus plus. Now what? You are returning 1 when you come out of the while loop. If you have not yet returned 1, you will return minus 1. Let's try. What is it? Cursum is equals to A of in 30, line number 30, in cursum equal to A of I minus B of J. Why is it? Okay. But this shouldn't be the B of J. Okay, current sum, I think I've taken int, that is why. It is lossy conversion. Okay, expected output is 1 and I'm returning minus 1. So what is the issue? 412 current sum is less than target. We are incrementing the count of, let me check where is the mistake. So here again it is not yet worked. Why? It is returning, let me check. N, it's sum A, sum B, that is B of I. If sum A minus sum B remainder 2 is 0, there should be some logical error only. Sum of A minus sum of B, it is divisible by 2, right? Otherwise, you're returning -1 because you do not have any such target. Fine. Then you have I less than m, j less than m, and m. Current sum you are taking ai minus bj. Current sum is target. Okay. You have got a pair and you are returning 1. Else if otherwise j plus plus. When you come out of this while loop, if you have not returned 1, you're returning -1. I think this should pass. Oh, we have not sorted the arrays. That is why this is giving you wrong output. Let's sort the arrays. Let's sort it before your while loop. Now let's check. This is done now. Fine. I hope you have now understood this problem. If you have any doubt, you can ask me. This is the problem you can look at. Coming on to time complexity of this problem. Let me check if you guys have any doubt yet. Okay. Coming on to the time complexity of this problem, since we are doing operation of sorting, we are sorting 2 arrays. Sort 2 arrays individually of length n and of length m. So sorting itself takes n log n, and other one is also taking some time of m log m. And then you are running a while loop of that iteration, in which, not in the worst case of time complexity, you will go through the entire array of a and b, right? So what would you consider? You can ignore these smaller values and it would be of n log n plus, because you've sorted these arrays, plus m log m time complexity. If, let's say, for example, if n is greater than m, you can say n log n of time complexity. It is still better than n cross m, right? That is why this is the optimized approach. No extra space taken. So this is all about your problem. So with this example, I wanted to show you, since even if we sort a and b, they are already in sorted order. We will get this array only. Now when I iterate over this, let's say my I was 0, my j was 0. So x would be 10. This is x. Let's say this is your x, and y is 5. This is what I'm talking about. So x minus y is what? This is your current sum. You're calculating the current sum. That is 5. 10 minus 5. Now 5 is not exactly divisible by 2. It's not equal to 0. So what do we want is, because 5 divided by 2 will be 2.5. 2 whole numbers you have. Can you ever get a difference which is 2.5? Never. You're not never going to get such a difference. So that means no such pair will exist, and that is why at that check only you are returning -1. That's why we have put this condition here, else return -1. So I hope you have understood this problem, the time complexity. We started with the brute force approach. Then we came up with an equation which helped us a lot in solving this problem. Just an observational based equation or expression. That is all about this problem. Then tomorrow onwards, we are going to start with another topic from your SD sheet, which is your searching and sorting, and we'll be doing the binary search question tomorrow. That's all for today then. See you all tomorrow. Thank you everyone. Bye bye.